All right, problem number 2 looks a little more complicated. We have 1 plus log base 3 of 7 plus log base 3 of x plus 3 equals 4. How do we deal with this? I don't know. First, let's isolate the weird stuff. So logs, they're weird. Let's isolate them. So we're going to subtract 1 from both sides. All right, on the left, 1 minus 1, everybody should know that's 0. On the right, 4 minus 1, that's 3. The other terms, they're still there. Okay, now how do we deal with the stuff on the left? We're trying to solve for x. We have 2 complicated things. What can we do? Well, is there any rule that'll make this a little simpler? I don't know. Which one of these rules has a plus sign? Oh, this guy. So, if we read this rule from right to left, what does it tell us? It tells us if we have the sum of 2 different logs, now they have to be to the same base, which they are, they're base 3. So be careful here, all these gotta be to the same base. Anyway, if we have the sum of 2 different logs, we can translate that to the log of a product, x times y. So how do we apply this here? We have a sum of 2 different logs. That's the same as log to the same base of this guy times that guy. So 7 times the quantity, x plus 3. Don't forget to put the parentheses here. All right, now what? Well, now we gotta distribute. So 7 times the quantity, x plus 3, 7 times x plus 7 times 3. That's all happening on the inside. So this is log 3 of 7x plus 21. Okay, now how do we get rid of the log? Same as before. We do 3 to the power of both sides. So I'm just gonna write little 3's down here. Maybe you can't see it because it's blue, but they're there. Okay? Rule number 4, we have 3 to log base 3. Boom, cancels out. The argument, the thing inside the parentheses, that drops down. 7x plus 21. The right, we have 3 cubed. Anything cubed to the 3rd power, that means you multiply it by itself 3 times. So 3 times 3 times 3, use a calculator if you want to, it's 27. Okay, now you know what to do. Subtract 21, 7x is 6. Divide by 7, x is 6 over 7. Boom. Now I know what you're thinking. You got the answer, but there's no way we can check this, right? Well, you're wrong. I'll show you how after I erase the board. All right, so we got this alleged solution, 6 over 7. Now we gotta check this guy. Check yourself before you wreck yourself. That's what I always say. Well, how do we check it? Well, same way you always check it, dummy. You plug it back in for x. Okay, what do we have now? We have 1 plus log 3 of 7 plus log 3, 6 over 7, because we plugged that in for x, plus 3 equals 4. Well, how do we check it? Well, first, you gotta get a common denominator. That's all you gotta do. Okay. So let's do that here. So we need a 7 down here. So we multiply this guy by 7 down below, 7 up top. It's still in the parentheses. Let's go. So what does it become? Well, 3 times 7 is 21. So we get 6 sevens plus 21 sevens. Amazing. Well, how do we check even more? Well, okay, add some fractions together. They have a common denominator. We just add them together. The numerator is 6 plus 21. That's 27. This guy's still here. This guy's also still here. When we check, generally we don't modify the right side. Only the more complicated side, which is usually the left. Not always. Sometimes we modify the right side. I lied. Okay, what do we do now? Well, we have additional logs. Guess what? We got a rule for that. You add, that's log of the product. So boom. Seven times 27 over 7 on the inside of the log. Okay? You multiply by 7, you divide by 7. That's the same as putting on your shoes and taking them off. That's gone. So we have 1 plus log base 3, 27. Okay? Is that equal to 4? I don't know. I'll put little question marks. We'll see. Well, how do I evaluate log base 3 to anything? Well, if I can write it as a power of 3, the rule number 5 says I can cancel it out, take the power down. Is 27 a power of 3? Well, what do you think? It is. 3 to the 3rd power. All right. So we rewrote it as power of 3. Rule number 5 says, boom, boom. They cancel. Boom, boom. 1 plus 3 is that 4. I don't know. Go back to kindergarten. We're good. It checks out. All right. Last but not least, we got a hard one coming up, boys and girls. Better hold on to your pumpkins because turnip cart is about to be turned over. Log base 3 of the quantity 3x minus 8 over 9 equals negative 2. Thought it was easy? You're wrong. How do we deal with this? Well, first step, we know how to deal with it. We gotta get rid of the log. So we do 3, which is the base of the log, to the power of both sides. All right. So in other words, 3 to the log base 3 of the quantity 3x minus 8 over 9 is 3 to the minus 2. Boom, they cancel. That's rule number 5. Okay, so on the left, power drops down. Well, that's easy. 3x minus 8 over 9. Who knew? I did. Okay, 3 to the minus 2. Well, what do? You gotta remember, you gotta use your brain. Anytime you have a negative exponent, that's 1 over the power to the positive exponent. So 3 to the minus 2, guess what? That's 1 over 3 to the positive 2. What's 3 squared? Well, if you don't know squares, that means you're a square. 3 squared is 3 times 3. That's 9. This is 1 over 9. 3x minus 8 over 9 is 1 over 9. That's correct. Okay, now what? Well, don't be a dummy. You gotta isolate x. How you isolate x? You gotta add this stuff to both sides. Okay, the left, negative, positive cancels out. Boom, fire and water. On the right, 1/9 plus 8/9. If you have 1/9 of a pie and you have 8/9 of a pie, guess what? You got the whole pie. So that equals 1. 3x equals 1. Now we got to isolate x even more. How do we do it? Divide by 3. That was easy. Okay, cancel. Boom. X is 1/3. Are we going to check it? Well, guess what, goofballs? We always check it. Check yourself before you wreck yourself. Coming up next. All right, folks, let's see if we can cash this check. How do we check it? Well, you plug in, same as you always do. Okay, plug in 1/3 for x. So we got log base 3 of 3 times 1/3 minus 8/9. Is that -2? I don't know. Who knows? 3 times 1/3, guess what? That's 1. These cancel out. Log base 3, 1 minus 8/9. Is that -2? It's a mystery. Okay. 1 minus 8/9. Well, what do we do? That's right. A comma numerator. Okay. 1. That's 9/9. We multiplied everything by 9. What's 9/9 minus 8/9? Subtract the numerators, you're good. Is this true? Log base 3 of 1/9 is -2? I don't know. What can we do? Well, we gotta write the inside as power of 3. Then we can cancel out by rule number 5. How do we do that? Well, I know that 9 is 3 squared. Okay, so what? It's still not a power of 3 because it's 1 over a power of 3. So what do? 1 over 3 squared is 3 to the -2. Get it? 1 over something is the same as the base to the negative of the exponent. So log base 3, 3 to -2, boom, they cancel, it checks out good. That's it. All right, folks, that's all for today. You should be feeling pretty proud of yourselves. You solved 3 problems with my help. Good. You better understand this by now. If you don't, you can't solve logarithmic equations, your life is a failure and you have failed. The end. Have a nice day.